Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about Denmark's energy island, or specifically energy island concept that has been popping up recently. So why do we exactly need renewable energy? Here's the deal. Nobody gives a damn about environment, and we can't blame them. But here's the deal. Everybody likes one aspect of renewable energy, meaning you don't care about Putin, basically. Right now, Putin can mess up the whole world economy because he thought he's bigger than everyone else. But reality is like he's corrupted more than anyone else, and that's why, Ukraine bitch slapped them. But reality is it created a very serious domino effect in entire world simply because of energy cost, and that creates a very serious scenario. Even though you can be independent, you are inherently not independent if you are not power independent. So, and it applies for everyone, like be it India, be it China, be it Russia, whatever have you. So everybody is now looking into renewable from a political point of view. It's like, bro, that gives me independence. And again, it will not be perfect, but no tool is, but at least it will give me, I got this, rather than I hope they are not gonna mess me up. So that's a very, very good thing. Now, wind energy is very large scale, meaning you don't even start talking about wind energy unless you are talking about multi-gigawatt scale. Solar is very good for like few megawatts. Wind, like it's a big boy deal. Like nobody is talking about like putting small, basically rooftop wind farms. Everybody is talking about like 5 gigawatts, 10 gigawatts, 100 gigawatt, that kind of system, but it works best in deep sea. That's why island aspect, and nobody wants to see or hear wind turbines. Again, looking part, I get it, but here's the deal. Again, you may say that's pedantic, oh, I don't want to look at wind turbines. That's a different thing, but here's the, you do not want to hear wind farms. Wind farms are very noisy. They are like giant airplane wings that are moving around. So of course they do create tangible amounts of noise that will frustrate anyone. So even the best, oh, environment, green and all that, if they have to live near a wind farm, they're like, dude, no more wind farms. So it's one of those things that you have to understand from a human point of view. Nobody wants to see it and nobody wants to hear it, specifically hear part. And there are giant requirements when you are building giant subsystems, that is HVDC converter stations. Now here's the normal substation can be made very compact, but HVDC substations are even larger, and they are ugly buildings. They are industrial buildings. You do not want to look at them, but you have to build them if you are transmitting giant amounts of power. So it's one of those things that I do not want to look at it. Like, for example, they want to think of it like a Nord Pi stream, like it's somewhere in the sea. Don't think about it. It's working. We don't have to worry about anything else. That's what people want, but they don't want, put into it. So that's the need. Like, there is a very serious need of going energy independent. Renewables are the best way of doing that. So what's the logic behind it? Logic is very simple, because majority of humanity has what we call not in my backyard. Meaning, you have heard many people complaining about oil pipelines, gas pipelines, specifically when they are on land. You never hear them when they are under sea. You never hear people complaining about, oil platforms, which are the most polluting things on this planet. But you don't see people complaining about. Why? Because you cannot see them. It's not like, oh, human dumb, human bad. It's like, we are limited creatures. We are not gods. We are limited. Like a doctor knows about doctor stuff, like psychiatrist knows about psychiatry stuff. Nobody knows about everything. So that's the reason. So that's why we have this, not in my backyard. For example, let's say Indians in many cities are like, especially very crowded cities, they're like, we want metro. Okay, we have to knock down these houses in order to, of course you have to do that. Nobody wants to do that. Like, again, really this happened. Like, there is a flyover built near me. Nobody is allowing them to, evict them. Like, again, even though government literally had the discussion with them, actually paid them, moved them, did everything properly, and then like, no, we want more. It's like, and if ever wondering why the heck China gets so many things done so quickly, it's simply because China does not care. It's like, it's civilians like, we don't want it here. Shh. Either you shut up or you disappear from this world. So make your choice. So that's why you have to understand this not in my backyard is a real thing. Like, I want metro, but I don't want my house to be compromised because of metro. So it's one of those things that you have to find a balance. So best way is you just remove it from looking at it. Basically, if you can't see it, you can complain about it. And there are hurdles in places. Like, again, those are very good things. I rather live in India, where like if somebody wants to take away my land, they're like, hey, at least give me fair pay, and they cannot just like poof me out of existence. So there are a lot of hurdles in play. But the moment you put things out of the sight, nobody cares about it. And like, this is a wind farm that has been taken down simply because of Indian protesters. So you have to know, again, they were taking over, forest land, but that's the one of those scenarios. Like, we also want renewable energy, but we also do not want to compromise land. You have to do something. So everybody desires a place where things get done. For example, oil farms, like these are amazing buildings, like from an engineering point of view, like these can literally handle tornadoes, like bro, tsunamis, typhoons and all that. Just like bro, what are you kidding? Like these are behemoth and they can survive for a century. And we have oil platforms that are 50 years old. They're like, we got this, bro. Like only bad things happen is the human that is bad thing inside it. Meaning if humans do not maintain it properly, then bad things can happen. But other than that, these things are like, bro, nature does not bother me. It's like, I got this. I genuinely got this. So these are amazing technology. So everything that we need in order to do Energy Island, we know. We got everything that we need in order to achieve that. We got it. And so psychological reason, not in my backyard, we got that part. Nobody is gonna create a hurdle because because nobody can see it. Nobody cares about it. It's like, oh, these are like such a tall, smokestack. Nobody cares about it. You can't see it. So that's the logic behind it. So understanding wind is a very critical aspect here, because you have to understand wind turbines are stupid if they are small. As in, that's why you will see a lot of small solar farms, as in like rooftop level solar farm, but you will never saw a rooftop wind farm. It does not make logical sense. Wind turbines have a lot of moving parts, so meaning they require maintenance, and maintenance do not scale up at the same rate as your turbine does. So it's far more financially viable to make larger turbine, meaning instead of making turbines that are 2 megawatt, it's much better from economics point of view to make a turbine that is 12 megawatt. Single turbine I'm talking about. And yes, there are turbines that are 12 megawatts, and there are companies that are claiming they are working on 15 megawatt turbines. So that's why we want to make it as huge as possible. That will reduce, basically what you are selling is megawatt hour. So if you are selling a lot of megawatt hour and your maintenance requirement goes down, like you still need one person to look at it, you still need that person to check it, let's say every week. Again, the numbers of turbine goes down, the number of people you require to check everything goes down, meaning profit. So that's why we want to make it as huge as possible. Now, can we do it on land? No. Why? Well, you can build it on land, but here's the how will you transport it? These things are huge. Because they are in sea, we do not actually understand the scale of it. Like they make Statue of Liberty look like a toy. I'm not even joking. Like these things are idiotically huge. Like I'm not even trying to imagine how huge that 15 megawatt one could be. Like there are image comparison, but again, there are image comparison. You don't actually get to see it. It's like Eiffel Tower looks small compared to it. Like that's how huge these things can be. So you have to make them huge, and you have to put a lot of them. Then only it makes sense to have like the substation, the HVDC links and all that jazz in order to, justify the cost of it. So you need a lot of wind turbines, and you need large surface area. Thankfully, oceans have all of it, and it does work 24/7. That's also desirable. And you may be like, what about predictability? What about like invariability, power output stability? Again, they are not stable. Let that be very clear. However, our predictability has become amazing, almost scary amazing. Meaning, at this point in time, a computer algorithm can predict what is power output gonna be 48 hours in advance, and it's creepy how good it is. Think of it this way, like somebody's gonna tell that wind farm, that's gonna produce 50 megawatt less in next 48 hours. And it does happen. It's like we can graph it out, and the real world power output almost matches it. It's like it's creepy how good we have become. And I'm talking about 2022, as in like 2020s. Right now, we may be even better. So predictable power is desirable power. And it does need maintenance. That's one of those things. That's why you need some place where people can stay. For example, large farms, they have a floating hotel where people actually stay there. Like around 6-month rotations, they stay there. So you need staff to maintain them 24/7. That's why you will see in Tenant's movie, like there is a accommodation for a person to living spartanly, but they can do that. All turbines can do that. And that's why larger the turbine, the more cost effective it becomes. And the best benefit of sea is transportation and deployment becomes super easy. For example, how big you can make it? Well, as big as your factory can allow you to make. So if your factory can allow you to make a jumbo jet size, kind of blades, do it. Just make sure you do it next to a sea, basically next to a port, and then you just directly dump the things to your, basically, boats, and boat directly take it to the final location. No transportation limitation, meaning you can make it as huge as possible. What about the pylons? There are a specific boat that can literally stand on the seabed and then hammer the pile in. Yeah, we have it. Like it's a real thing. That's why like offshore wind farms are becoming so big thing, and that's why nobody is talking about wind farms on land anymore. Everybody's like, yeah, wind farms on land looks a good idea, but it's not viable unless you literally have a very large place of land which is not occupied by anything, for example in some places in USA, and then you build a wind farm right there, so you can build as huge as possible. Other than that, it's not going to be viable. But sea removes all that issue, meaning you can manufacture as long as you have basically a seaport, and you can deploy it wherever you want. So transportation deployment becomes easy in the sea, and sea has enough surface area for expansion, meaning you start a plant as, let's say, hey, this is 1 gigawatt plant, no problem, that's a good start. And you're like, we want to scale it up to 10 gigawatt, no problem, you can do that. It has enough surface area, we're not going to run out of surface area. So wind is amazing in that scale. So we come to another aspect. How the heck you going to transport the energy? Well, you can't transport AC. AC does not go very far, so we have to use HVDC. And why does not AC go very far? Because of capacitance loss, meaning because it's turning on and off, it's acting like a capacitor. And if you're sending power through sea, good luck trying to send it above 80 kilometers, meaning the moment your distance goes beyond 80 kilometers, if you send even hundreds of gigawatt, it will not go there. So you have to use DC links. They are expensive. Like very expensive. HVDC is expensive on land. That's why we on land, if you are using air conductors, we still only use it if we are crossing more than 500 kilometers. Undersea, it's more like 80, but above, land, it's around 500 kilometers. So if you are thinking about making a link that is 1170 kilometers, another link that is like 1250 kilometers, another link that is 1500 kilometers, 400 kilometers, around 2000 kilometers, you have to use HVDC and interconnects. That's the dream goal of basically entirety of European Union, because yes, look from a power plants per point of view, they never want to tone down their generator. Why? Because they're paying their employees in per month. So how you're making actual money? You're making actual money based on units sold. So if you can maximize the units sold, you're gonna maximize your profit. So they never want to tone down their power plants. Even if it's a coal power plant, even if it's a nuclear power plant, even if it's a hydro dam, they never want to tone it down. They want to maximize it. How can you do that? Because yes, the city does consume a lot of power, but it also goes down. And so in those situations, having interlinks, you can be like, bro, Iceland is producing too much hydropower. No problem. England is like, we got this, fam. We're gonna consume it. Germany is like, dude, we have power deficit. Norway is like, bro, I got you, fam. So that's what Europe wants to have at the end of the day. Whereas like all these countries, all the power plant would be working at max capacity without too much issue. And same goes for wind turbines. Many times you will see wind turbines that are stopped. It's like many of the time they are because of maintenance. Majority of the time it's because of curtailment, meaning it's overproducing the power. So you never want to turn it off, meaning turning off a turbine. Again, maintenance down is a different thing. Turning it off because of curtailment is a loss for a company. So they all of the companies want interlink. So that guarantees everybody is stable. Interconnects need large substation. For example, if you have to make an AC substation, it's just like you take 11 kV in, 3-phase in, you YOLO it up to, let's say, 500 kV. That's it, done. 500 3-phase comes in, 500 kV goes up, 3 kV, 3-phase line outputs. But in HVDC, that's not how it works. You basically take 3-phase in, you max it up to basically high voltage that you're going to transmit. For example, many of the undersea links are around 500 kV, and some of them are like 750 kV. So you step up the depth, but your transformer are double transformer, meaning it's going to take 3-phase in and going to make 6-phase output. That's why like this is the world's largest HVDC transformer. It has one input and 2 output. So you use 3 of these transformer to take 3-phase in from your generator, YOLO it up to like 6-phase. Then this 6-phase data goes into what we call converter station. That converter station makes the AC into DC, and then you transmit that puppy. Expensive and large. So making all of that unit into this is made by ABB. It does work. It's one of those things, it does work, but it's very limiting and very idiotically expensive. It's expensive, meaning they have to design it without any margin, meaning it's like, hey, let's say this is 2 gigawatt link, that's it, done, 2 gigawatt. Because again, you cannot just go there and replace the transformer. Even though you can have a boat, you can go there. It's like, this transformer takes too much space. You cannot physically change it. And again, many of the things are integrated so well. It's like they have to disassemble everything in order to take one thing out. So interconnects require large substation, because AC substations are like small. HVDC substations are exponentially larger. Again, transformer count become double, and you need a whole substation, as in converter station that is converting AC into DC. And many of the time those are two-way system, so very expensive. So many things become easy on land, like many things become easy in sea in terms of wind turbines, but opposite is true for substation. That's why you need large area, and you really do not want to pack everything in this quickly. Like, compact. Again, you can do that, it's just cost. And not to mention, it also makes it very difficult. It's like, hope that you know your power requirement in future. So it's like, it's 2 gigawatt. Again, who will give you a loan if you want to make it for 10 gigawatt? It's like, so maintenance on land also becomes very cheap and easy. So these are the problems of HVDC. Wind likes open sea, HVDC likes open land. So this technology, basically, this is a trial technology because we know everything about that is being used here. We know everything about it. Can we make artificial island? Dubai has been making it as a fancy guest house. We know how to do it. What about HVDC links? We have been making it. China has like 12 gigawatt link. India has a world's first tri-link connection, meaning it transmits power from A to B to C. Majority of HVDC right now is like A to B. India has A, B and C. That is East Agra link, that is 8 gigawatt at 800 kV. So we got that part also sorted. We got the wind turbine, we got the HVDC, we got the artificial island. So what's happening here is the government is taking a leap of faith, 51% ownership. So public do not get like, hey, you are selling land to private corporation, 51% lease. So controlling authority, 49% because again, if government have to do everything, the red tape itself will destroy it. So 49% would be private partnership, and they will design everything. And that's why you will see multiple designs for same island, because right now they are in the bidding phase. So you will see multiple designs. And sea makes many things easy. For example, giant wind turbines, transportation, deployment, awesome. Land makes many things easy. For example, giant substation, giant places where people can stay, because the people who are working on wind farms, they are very specially trained people. Why? Because they have to be best of the best of the best in terms of motion sickness. Because you're gonna be staying on a boat 24/7 into 6 months. That's brutal. And again, if you can be like, hey, you can be there, but here's the deal. We have an island where you go at the night to sleep. Everybody is like, no, we can tolerate. Majority of people will be able to tolerate that. It's like whole daytime you'll be like this, and nighttime you sleep on a solid ground. You're like, I can take it. More people can tolerate it. Benefit, your labor cost goes down. So land makes many things. And again, substation, you can make it as large as interconnect as large as possible. Like you'll be like, hey, not from A to B, A to B to C to G, E to E to F to G. You can do like, I got this all. So many things, it becomes easy on land, many things become easy on sea. Island is the best of both worlds, meaning as long as, like, for example, Hitachi makes the transformer next to a port. Of course, majority of the plants are built that way, so they can transport their things to port. Port to island is super easy. One step shop. Don't think about like how the heck you're gonna move trees, how the heck you're gonna move around the bridges. No, done. So island makes best of that. People who have motion sickness, they are on solid ground. They don't have to worry too much about it. And scale can be used for growth. For example, you will build the system. Again, the land will be designed in such a way that it should provide enough space for 10 gigawatt substation. Again, they will start with 2 gigawatt and then they can scale it up. And they're like, let's say in future, it really works, economics supports it, and they're like, bro, we need to 200 gigawatt. No problem, sir. We can just increase the island size. And this place will be used for raw experiment, meaning there are so many companies that are working on basically trying to make shipping work on ammonia. I have no idea why, but they are working on it. But they need a lot of power, and they need a place where they can just work on it, and it has more than enough energy to can actually work on it, as in like megawatt or gigawatt class reactors. So in those sort of scenarios, this is like, bro, work on here. And again, ammonia is a hazardous thing, so you do not want it near civilian population. So that can be done. So basically, and many places like, we want hydrogen, even though it's a stupid fuel, but we want hydrogen. Okay, work here. Nobody cares about it. Nobody. And again, if it works, awesome. Public will get the final product. If it does not work, no problem. Nobody will notice it. You just keep on working. So island park works, HVDC substation works, basically wind farm works. These are the 3 core pillars of it. Everything else is just seeing how the economics work on it. And that's the whole point. In the end of the day, they will have a place where just like YOLO in terms of experiment. Just go YOLO. And all of the designs have certain requirements. For example, they have to be designed in such a way that they can, like, sea rising should not be an issue. Like, has to be really tall. And second, all of them should have good access to ports, as in like, that's why all designs have like very good port design. From day one, it's designed in such a way. And some designs are so huge that they have runways in them. I mean, small class, basically 10 to 50 or even 100 passenger planes should be able to land there. So it's a very large scope plan, which will start in small scales, as in like 2025, and then will slowly grow in 2030s. And even after that, that's the whole point. And this is just one project. There are many projects similar to this being considered everywhere. So Denmark is like, bro, let me establish the foundation, the payload, the blueprints and all that just. Then all other companies can like just look into it and just expand it. And hopefully this 51-49% partnership works. Because as I say, physics, engineering, economics must work. So this was my presentation on Energy Island. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.